Let's see the theorems on the limits of function. We have 6 theorems in total, and let's just get right into it. So first we assume that we have two functions f and g, and the limit of f of x as x approaches a is equal to L, but the limit of g of x as x approaches a is equal to m, right? So both of these functions have different y values for when x approaches a, right? So they can basically just say it's like this. Uh, say this is one graph and this is the other graph. So obviously you can see that if we say that this here is a, the limit over here is different and the limit over here is different. So two different functions. Okay, so let's see the first theorem. The first theorem states that if we can basically write down the limit of x approaches a of f of x plus the limit of g of x as x approaches a. You can write that down like this as well. You can take the limit common from both of them and it'll be the same thing. It will become L plus m. Okay, so the first theorem states that you can take the limit common if they both have the same limit. Okay, if they're both being added up, you can take the limit common. The second theorem states that the limit of the difference of two functions is equal to the difference of their limit. So it basically means the same thing. In case of both addition and subtraction, you can take the limit common from both of them, and that in this case is equal to L minus m, because limit of f of x as x approaches a minus limit of g of x is equal, the limit of f of x as x approaches is L, and limit of g of x as x approaches is m with a negative sign between them, right? But you can take the limit common. Okay. The third theorem states that if k is any constant, then basically if we have the limit of k of f of x as x approaches a, it is basically equivalent to as if you take the k outside and you multiply k with the limit of f of x as x approaches a, which is equal to L. So that becomes KL, right? The fourth theorem states that the limit of the product of the functions is equal to the product of their limits. What that means is this. Basically, the limit of the product of f of x and g of x as x approaches a is equal to the limit of f of x as x approaches a multiplied by the limit of g of x as x approaches a, right? So in this case as well, you can take the two limits common outside as 1 and multiply the two functions, and that just becomes L into m, right? The fifth theorem states that the limit of the quotient of the functions is equal to the quotient of their limits, provided that the limit of the denominator is non-zero. See here, basically the limit of f of x over g of x as x approaches a is equal to as if you just divide the limit of f of x divided by the limit of g of x. But you have to remember that this term here cannot be 0 for this particular theorem, right? Because that becomes, once you have a 0 in the denominator, the term itself becomes it does not have any value. It becomes infinity. It gives you a math error. So as long as this is not, the denominator is not equal to 0, this entire thing over here is equal to L by m, right? So you can take these two limits common outside as 1 and then just divide the two functions. Okay, so Now, the limit of f of x whole to the power n, where n is an integer, basically means that if you have the limit of f of x whole to the power n with as x approaches a, you can basically take it as the limit of f of x as x approaches a whole to the power n. So that becomes L to the power n, right? So these are the 6 theorems, and you can use them to your luxury. The only thing that you have to remember here is this particular case, right? Over here, this g of x and this m over here, they cannot be equal to 0 because this whole thing becomes undefined.